Evening to all here for the September Tech Night, which VK5KK. David is going to talk on going from an idea to a circuit to a PCB, and obviously construction as well. So hand it over to you, Dave.
All right, thank you, Wayne. Okay, so it's going to be a bit of a tour of printed circuit boards. We're going to end up, the main part of the talk will be looking at what you can do now, but a little bit of background. I think the first printed circuit board I did would have been about 1973, before there were Dalo pens, but using textures on Bakelite board and things like that. And it probably was a high school project, and it probably looked ugly, and it's probably still in my attic somewhere. So yes, so printed circuit boards, been through the whole part of doing it yourself with ferric chloride, and then graduating from, never really used Dalo pens, but went to Scotch scale film, the orange film. I don't know if anybody has done that back in the early 80s. You could, it's popped up online. I think I've still got some of the old original ones we did. So that was using Letraset type tape, and there was an American company, you could buy a packet of sort of rub-on transfers for integrated circuits and things like that. And then late in the 80s, Protel, using DOS Protel 1.56. It was around about 1988, got lumped with the VK5 Division Equipment Supplies Committee after Bob Murphy had passed it on. And it was around the time that the VK5 2-metre preamp was released. And that was a professionally designed and made board by Imp back in the day. I don't know if Imp's still around these days, but they were owned by Codan. They used to make all the printed circuit boards up at Newton, then used to do them at Jepps Cross later on. Anyway, one thing led to another, but started doing printed circuit board design on a computer. So those that have used Protel before, this is DOS Protel, did use the Windows version a bit. But basically, you started with a drawing, which was a hand-drawn sketch of the circuit, and then designed the board from there. So there was no link between the actual drawing, it wasn't in CAD, to link to the actual design. So that was good, but generally it would be fraught with errors because there was no lookup as far as the board went with the layout and the circuit. But in the end, probably did about 60 boards past this round. This is one of the early ESC projects. I used to number them up to about 96 now, but this is number 15. And that was probably the most complex one I did at that stage, but done on DOS version of Protel. It's a reverse transverter, which turned to be about the second or third most popular kit we ever did. It was 2 metres in and 6 metres out. For some reason at that point in time, there wasn't very many 6-metre rigs around the place. Everybody had a 2-metre set. So instead of doing a transverter from 28 megs, it did one from 2 metres. Actually did a 28 meg version of that as well. So that board took about 2 months and 2 prototypes to get to the final stage. We were lucky at that point we weren't using a commercial organisation to do the boards. The early boards I did myself. So we had Scotch scale, but did that actually with a proper printout. And then in the end, Norm VK5ZAH started making the board. So we actually had sort of we'll call it semi-production type thing. So that was my foray into boards. Ended up doing quite a few other different types of boards. Even did Duroid boards. So there's some of the leftovers of the old kits. There's a 10 gig multiplier. That was an 11 gig multiplier. So these little short form. So we did quite a few of these. When the ESC, Mark Kilmar got involved with that. The rest is history. That was the beginning of mini kits. And Mark took over around about board number 48 or 56, I think. He's up to board 200 and whatever these days. So I didn't do many printed circuit boards after that. Did a few things commercially. Gawler, actually all the little lights and notifiers and things that are in the Gawler hospital were all made I designed the boards and Norm made the boards, so that's all local production, all the electronics through there, it's still in use. These jumbo LEDs above the doors for indicators and things like that. So that was sort of an interesting sort of spin-off. I think Whyler Hospital got the same things too. So that actually gave Norm a bit of work to make all these boards. He made them all up and kept him going for weeks and weeks and weeks. And they're still there working 25 years later. I didn't do many printed circuit boards after that, and probably did the odd one here and there. Started using Protel, things moved on, and it wasn't until mid last year really started getting back into doing printed circuit boards, and it was the 122 project. I mucked around with Eagle a bit and done some other boards and sort of designs and things, but decided to jump into it and learn Eagle. Hindsight has 20/20 vision. Eagle's perhaps a fairly old program. There are other ones out there, but it had a large library, pretty easy to use. You could drag CAD into it. There was a fusion program. You could design mechanical bits with it and everything else. So just stuck with it. So my first printed circuit board I made after about 20 years was a 4-layer board using 0603. Nothing, nothing like learning, from the, I don't know, I've got it here. I probably forgot to bring it. The original prototype of the 122. So in the end, that's not the first project, but that was pretty close to the first project. Should have brought it. And did the board, and it worked. I think I made one tiny mistake or something like that. It was a 5-volt link wasn't there or whatever. I've made bigger mistakes since then doing boards. But the difference between the old Protel and Eagle is, with Eagle you start with a CAD drawing, you start with a circuit. So if the circuit's right, the board's right. So that was the biggest problem whenever we were doing all these other things. Once you got to something complex, yes, you could do double-sided, but because it was all optical aligned and everything else, no plated through holes, all that sort of business. What's happened in the last 20 years, or perhaps the last 5 or 6 years, is the maker community have started making printed circuit boards. And now, if you want to etch a printed circuit board, you're only doing it because you want to make valve radios or something like that. You can send a file to China and get your boards done for about 50 cents each, or even less, depending on the freights. The freight is often more than what the boards are. So you don't get too worried about making mistakes, and there's a couple of mistakes here, but only very minor ones. So that's went through with Eagle. So what I'm going to do tonight is just quickly run through what is involved in setting up the circuit. If you've done any sort of CAD, or not even CAD, the beauty of these programs now is they have all your standard resistors, capacitors in there. They have a lot of the semiconductors, but if you don't have the footprint for the semiconductor, you go to here's a plug, Mouser or DigiKey, click on there, and they all have libraries that you can use. And if they don't have a library for components, some of these guys, you just send in a request, and for free they'll do the part for you. Thinking that they're going to sell 2,000 ammeters turn up, buy 2. Or you can actually make them yourself. And for some things like modules and RF transistors and things, it's probably better if you do it yourself, because you'll get the lands right. You look at the tech spec, get it all measured up, and away you go type thing. So the project we're going to look at when this comes back to life again, there it is. Okay. There's always a story behind making printed circuit boards. A lot of the ones I've done in the last year and a half are microwave related. There's been up to version 2.1 of the 122, which has a lot of mods that Ian came up with to work with his software. So that little board there, that's half populated. We'll pass that around shortly. The beauty of this is if you end up with a few spare boards of something you used to use, you can use it as a breadboard to test things out on. The board cost $1.50, so what's the problem? It changes everything you do. If you've got a bit of time and you want to do a board, you're better off doing something like this. if it's like version 1 and you're just trying something out, you can do a run of these boards for $5 or something like that. And what I do is tend to batch up about 3 or 4 and put them in the one order, and then it's just the one lot of DHL, which is $15 or $17 or something like that. So the quickest I've got to turn around on a board, I think, was some of these ones I did here. From the start of the design, did the design in one night, that's the circuit up there. Sent it off, I had the board back, it was made, because it's only double-sided, so it takes about 24 hours. Had the board back within a week from China. So plated through holes, solder masked, everything. So I'll probably sit down and just do some of the circuit stuff, show you how this all works. So this, I'll pass this board around. A couple of you know what it is. There you go. A little obscure board. I could probably zoom out and you'll see there it's IC910H driver. Now the IC910H has a driver chip which is actually the chip that was used in the original FT817s, and they had a habit of exploding when they were new. The heatsink of this particular FET is not that good. It's probably okay for sideband, but when you have a father who likes to run JT65 or Whisper for about a day, they have temperature issues. So after the second go at replacing the FET on the original board and the lands all came off, I just made up a board. So that took about 2 hours. Very simple circuit. And all I had to do was measure up the original board, get the holes right, and the mounting hole, and away you go. So typical circuit, it's very simple. It's got resistors. If we want to know what that resistor is, we just right click on it and go properties. And there it is. It's probably a bit hard to read. But what it's telling me is it's R2. It's a 200 ohm resistor. It's a 2512 SMD, so it's a big 2 watt SMD resistor. So another one there, these capacitors. Click on properties. So it's C1, 470 PF, 0603. So 0603 is a little tiny flea-sized capacitor. Now if I want to change this, if I want to change any of the values, it's just a right click. You'll see that I've got the layers turned on so I can see what the values are. So there's all the values there. These are all library items that are the actual pinouts. If I want to add something to this circuit, menu bar on the left-hand side, which is probably very hard to see, but take my word for it. It says add part. Click on that and up comes the menu. So let's say I wanted to do something stupid and add something like a BC547. Hit BC547. It will find BC547. I really should have gone SMD, so I really meant to use an 847. Go 847. There we go. Click on that. Okay. There's my transistor. Simple. So I'm just going to muck around here. Nothing that's really sensible, but I do that. Oh, I could do another one. I only need one, so hit escape. So I really want to, let's just make a bit of room over here. Drag this around. Move this over here. So I'm making another little circuit. Now I want a resistor. Now 2 things you can do here. Instead of going over here and place a part, I've already got resistors here anyway. Copy. Here's my resistor. Now there's one thing I need to do is change the grid scale. Reason for that is it will then, I don't need to copy it, but I just want to move it. I could then align things up like this. Now I've just put a dirty great big resistor in there. I probably don't need to have one that size, but I can change it later if I like. Now I want to connect those two. Let's put a capacitor there. Let's do this properly. Copy. Do that. There's a capacitor. You can move around the designators so they're not, see it's attached. I'll just put over there so it's a bit neater. Typically do this at the end. I want a ground connection. Oh, here's a ground connection. Copy that. Do that. So we're starting to get a bit of a circuit here for an amplifier. Now, I want to connect it all together. There's a little thing over here called net that creates net. So a net is, very simply on a printed circuit board, a net is basically a wire that connects all things on the same, zoom in, see it? On the same connection. So we'll just do that. We've connected the two. Want to connect up to here, do that, connect. There's a junction. Want to connect to this resistor here, bing, there we go. I want to connect to the ground, bing. And it's going to ask me there, do I want to connect net 6 to ground? The answer is yes. Bang. There we go. So you just get your circuit, draw it out, away you go. Don't get too worried about the values. I typically place everything in what I'm looking at to start with and then come back and change the values. So you can just, let's just copy this, got to put that up there, copy that, put that there, copy that, no, don't do that, give me a bit, put that there, shuffle some things around so it makes a bit more sense, put that up there, put that over there, put T2 up there. Typically, I've actually got these, you can change the size of the fonts. That's C3, put there, that's a bit better. That's 50, so I'm going to change that. 1F and F there. So let's make this, I'm going to change the value of this to 4K7, 4K7, apply, change this to 2K2. You can use whatever, you can go 2.2K, 2K2, whatever. All that does is when you do your parts list, it'll just reflect that in your parts list. 56 ohms. Let's make that 150 ohms. Ohms. Should really shuffle that over so it's a bit more obvious. So now we're going to connect it all together. So you can do this in any order you like. I've just connected those. Disconnected. Now I haven't aligned that very well. Escape. You can shift these things later, but it's always nice to have everything so lines are straight. You can turn a grid on. Yes, I've got grid. I've got a habit of turning the grid off, but view, we can make it dots like that. No, that's not working very well. Grid, display on. So there's dots, or what's probably better is lines. And I'll wind it out so it's 50 mil, so it's a bit more obvious. Printed circuit boards still work in imperial. That's, there you go. I know it's not really easy to see, but there is a grid there. It's not very, it's visible on this, but not on that. But
is that because it's yanked organised?
Oh, it's just, it would be just the screen. You can see it on this, okay? But there is now, for now everything should sort of line up as it should. Continue doing my amplifier. There we go. That's just go back. Edit, undo. I've got to go back to 10 mil. One rule of thumb with these things is once you set your grid up, don't change it because you have to lob straight on the right spot for it to work, which it does there. That's pretty ugly, but that'll work. That's sort of an amplifier really, haven't we? We just need a couple more capacitors. So I'm just going to pinch some more capacitors, copy. If you want to turn, see that there, whoop, 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 that's the right button. So a lot of the navigation is just purely on the mouse. So if you want to turn your capacitor around, you can back it right in if you want to. We're connected. Oh, I need one on the output, copy. Back that in there, bang. Really, I should have moved that onto there, so let's do the right thing. Generally, when you do circuits, it pays a little tail on there, because then you can shuffle things around. You can, let's say you wanted to move a particular part, you can do that. If you're trying to shrink things down, you do that, and then you bring that back up. And this is pretty ugly here. It's not a good thing. I'm going to make that a little bit better. You zoom in and out is the wheel on your mouse. Already connected that. There we go. So there's our amplifier. Now what I tend to do is do the design first. If you know the values, then go back over the values, set them up. But if it's something experimental which you don't know the values, especially resistors and capacitors, it's the same size physically on the board, so you can come back and do that later. But what we've got now is a circuit, basically. Now, if you want to work out, it's probably not very easy to see, but if you right-click on one of these lines and want to know what it is, it'll give you a descriptor, so N4, but let's say that's a 5-volt line, and that's what I'm going to call this. I'm going to change its name to plus 5 volts. Do that. There's the symbol, it's now plus 5 volts. If I want to connect this to this plus 5 volts, you can draw a line all the way across there if you want to. So you just do this. Zoom in. That's joined, so it's plus 5 volts. But let's say you're doing this little tic-tac-toe thing with lots of different circuits. Let's get rid of this. Let's get rid of this. All you have to do is change the name of this little circuit, this section over here, to plus 5V. And it says, do you want to connect it to 5 volts? Yes, I do. When we come to the actual layout, that will automatically link the two together. So if you're doing little pieces of circuitry putting together, you can build them on several sheets and just have sections here and here and here. Don't worry about joining the lines together. Just have little tails and just name them the same as where you want to connect it to, and that could be a meaningful name like RF input. It by default gives it like a net N dollar number. You can use that, but I just like to use all the rails because it will give you the name. There's the name, you know that's 5 volts, you know that's 5 volts. So there's our little circuit. That's half the story. So if you're happy with the circuit, everything looks good, you check it, that's fine. There's another panel, which is the board. So this is the board, the little red board passed around before. In this view, I have all the actual nets, the tracks shown, but I don't have the ground plane shown. You can turn the ground plane on and off, but you'll see all these little wires. These are plated through holes all the way around to stitch the top and bottom layers together. And then this is the big mounting hole. So on my screen here, that's about yay big for that. You can zoom into any part you like. Here's the 4-pin connectors. That's the output. That's the input. It's a very basic circuit. I don't know why they had this as a separate circuit to the main board. Maybe because they kept blowing them up, because they certainly do that in real life. So all this has is just 2 pins, and this is the pitch of these is 2 mil, not 2.5 mil, so it's not 1/10 like a normal header. So it's just 2 grounds, 2 5 volts, and 5 volts is also the RF out, and the input is just input and ground. Very basic circuit. So that's that, but let's zoom out, and here is the components we just placed down here. So there's the BC547. There's all the components we just placed. So what you do now is arrange them in what you think is a logical way to arrange the circuit. I'll just zoom in a bit, so what's that? It's a bit hard to see, isn't it? Okay, I can see, I have to turn that around. So I've just got to drop that, that's the resistor there. You can just see those yellow lines. The yellow lines let you know what is connected to what. I'll have a play around with this afterwards, but what I've done there, that's on the emitter, that's the resistor and the capacitor. They're now side by side. If I zoom right in, you can see that's the ground, that's the ground. That's actually better, isn't it? And there's the emitter. So the little yellow line goes doot, doot, doot. All three are connected. Now to join those, I click on route air wire, and hard to see, but up the top here it brings up a track width. It defaults to 6mm. I don't need to use 6mm, I'm doing that sort of stuff there. So let's make it a bit chunkier, like say 12 or 16mm. And to join them, I just go click, click, click. There's your tracks. Drag some more resistors over. Now you can do, I quite often have a circuit sitting there, so I'm doing, but you can do this totally random, because it'll tell you what is connected to what. So that's one of the base resistors. Just going to do a, let's go do a quick, you can do auto placement, yes. I'll show you that in a moment. For all the microwave stuff, I tend not to use auto placement because it's dumb, but for digital stuff and things like that, yes. That's the input capacitor. That is the resistor there. That is, oh, that's, I know what that is. Let's zoom in. That's there. That's right, because that's the base up the top there. Let's make it look a bit like that. That's the collector there on the transistor. What it pays to do is get them all roughly in the same area, because the one thing Eagle does, it just, when you put it on the circuit, it just has this great long string of parts. So what I'll do now is, oh, there's one out here. Make it a bit easier to see. Okay, so they're all pretty well on the same page now. That capacitor's not connected. You can soon see if you've mucked the circuit up, that capacitor's floating, so I need to go back and look at it. So then you just do a bit of alignment so things look a bit better. Maybe line that up down there. That's the capacitor. Might just do it like that. Do it like that. There's a little bit hard to see, but you see a red outline here. That's the boundary of the parts, so you can bump the parts right close together, like so. I think that capacitor, let's go back to the circuit, see what I've done. Now, that capacitor hasn't connected. That was why it was still floating. It's now connected. You soon know you've stuffed the circuit up because you've got to have things that are floating and not connected to anything. We might just put that there. This is a bit of a random one. But it gives you a chance to shuffle things around. Now, if you're trying to fit in some additional circuitry in something, you can shape it however you like. But that's our circuit now. Probably bring these things down here. Depends how keen you are to have things close together. I think that's probably better like that. So you can play around with it. What I tend to do is save different versions. So I've got to that point, I'm happy with that, but I might want to change things. So I'm just going to save as demo 2. So you've got the one you had before. So if you don't like it, you can go back. You can undo things, but now we've got pretty well everything set up to join everything up. So zoom in, we'll see our yellow lines here. Hit the air wire, we go from bump to bump, bump to bump, that's all joined. We then go here, and where's this got to go? It's got to go to there, 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 it's all joined, 5 volts to here. That's everything joined.
You didn't do that with straight lines?
Yeah, you could, now with auto routing, you can do auto routing. It's, for digital circuits, probably the best way to go, otherwise you go crazy. For analog circuits, you just visualise, it's pretty well laid out the same as your circuit. So that's it. Now, you'll notice there's 2 wires here. One of those is the 5 volt, and one of those is the ground. Now, what you would normally be doing, this dotted line here is the boundary of the board, and you'll see it's black inside that. The whole aim is to actually have that inside there. Now, you've done that, you're pretty sure it's right, but wait, there's more. There's error checking. We'll do error checking on the board first because that will then give us a list of problems. And there's a whole heap of air wires here. You just can't see that. The reason there's air wires is because I haven't filled in the ground plane at the top here. To fill the ground plane in, so this is, I click one button, this will then join the ground plane together. So that's the final board. Usually don't do that, it's the last thing. You know they're all ground, but once you've got that, it looks pretty busy. A bit hard to see what's actually on the board. If we go back to errors now, we'll find that most of those errors have cleared. There'll still be some errors. Okay, we're back to 4 errors now. And the errors will just simply be the connections down here that we haven't put in, the yellow wires. So while there's yellow wires, it still indicates that there needs to be connections. Now what we've got is a number of ground connections that aren't connected. Now if this was within that boundary, it would automatically link all the grounds. Because it's not, I'm just going to do this. It doesn't like that because it's on the wrong layer. So we'll just we've got ground connections down the bottom. There's 2 ground connections here. So all grounds are connected together there. I won't take it all the way through. Now two errors, and that's just the ground and the plus 5 volts that we haven't connected. So that's it. Now, next step, check your printed circuit board, print it out, have a look at it, go back to the circuit, make sure the circuit's okay. I've used quite large resistors here, so that's fine. Capacitors are all good. So that board, what I'll do, I won't use that one because it's got errors, but I'll go back to another board. to the original. Open recent. Let's pick that one. Okay. There's actually 3 screens. It's probably a bit hard to see. This is the more complex. This is one of those boards over there. There's the board layout. So that is, I think, that's the phase lock loop one. What I'll show you now is just a completed board and what the different options are. At the moment, I've got pretty well all the layers turned off except the component layer. Now, this board has, I don't know if you can see very well, but there's notches all the way around the board. You can do quite complex shapes. Which one's that? Here somewhere, thought I brought it. Here we go. That one there. That's a prototype phase lock loop. If you look closely, it's got little tiny notches. It's got a notch for a connector. That's designed to go in one of those tin plate boxes. So there's notches where the folds go. So that'll drop in a tin plate box. This is the bottom side. So this is actually the side of that where the DC components are. What I've done for clarity, so I can print it out, I'll just flip it so you can read it. Flip board, that's around the right way. It's turned off the layers. It's the bottom layer, so what I'm going to do now is turn on the bottom layer. There's the tracks for the bottom layer. This is a double-sided board. There's a menu over here. You can turn on and off layers as you need. So you typically you start from one side, then work with the other. There's the top side. So what I'm going to do now is turn off the bottom, turn the top on. And must be a few other things I need to turn on. Do that. Flip it back, flip, view, flip back. And there's the top layer. And that's the notch over there. That's actually an SMA connector that slides in there, so it's recessed. Up the top, that's a notch. So this bit's basically you just draw around what's called layer 20, which is a dimension layer, and draw your outline. Then everything that's inside is the board. And you'll notice, I don't know how well you can see it, but there is red, it's going very well, there's red dots around the outside. There's like a border you put around. And that border is ground. So anything that's marked ground inside, like these vias here, all I have to do to actually draw the ground plane is click on that. There's the ground plane. So that's the final board. But for clarity, when you're doing things, you leave the ground plane switched off. Now, the board I'm passing around is double-sided, but it has 2 layers inside. So it's a 4-sided board. And while 4-sided boards sound like they're complicated, they just make life so much easier because you can get rid of all your links, but you can also hide different, like sensitive inputs to op amps or other voltage rails, whatever, between 2 ground planes then. So if I want to see what the inside looks like, let's just turn off the top. That's the next layer down. So what I've done here, all the digital circuits are stuck between 2 ground planes to shield them. So it's just an Arduino. So all the digital circuits are run from the Arduino. Some chips over here are all stuck between 2 layers. And then couldn't run that top or bottom, so I ran I think that's a voltage one through there. And then you go one more layer down. Here's some more stuff I couldn't fit. So this is like, I think, 2 more data. That might be the TX and RX, RS232, and some more voltage rails. So professionally, they usually have actually power planes between the two. For this sort of stuff, I thought, well, just hide all the digital stuff so it's shielded between 2 bits of ground plane to reduce the noise. So all I've done in those middle layers is just use them for what you'd normally use for links. Now, every time you place these little donuts, which are called a via, it's plated through via. That goes through the whole board. So it's not a blind via. It appears on the top and the bottom and just links straight through. So a little bit of management to get them in the right spots, but it makes testing the boards easy. And I've never done it, but if you fuse one of these inside layers by shorting something out, at least you can still hook a wire up to it. But haven't done that yet. So what we're going to do is use this board and order a board. Now what we need to do is create Gerber files. So Gerber file is basically a CAD file. It's in G code that has all the layers, has the drill sets, all packaged up in everything the printed circuit board manufacturer requires to make the board. Different programs do the same thing. Eagle has a pretty simple processor. Comes out as a RS274X type Gerber file. So I just do that. Most printed circuit board manufacturers want it sent as a zip, so you click zip, click process. It'll ask you to save it as something, so I'm going to call it a random one because it's not a production one. Do that. And it'll tell me in about 5 seconds that it's done. Job done. Clear that. Save the cam job. Call it something else. Demo. I've got my printed circuit board. So now I can go to one of about 50 Chinese manufacturers to get my board done. There are some Australian ones who'll do it too. It's this is going to go on YouTube. I can't talk about some manufacturers, where they send things. There's different ones around. There's PCB Way. I'm going to use JLC PCB tonight because that's the last one I used. So we get their website. SMT auto assembly temporarily limited to 10 pieces. They must be flat out. There we go. Here we go. I'm just going to log in, sign in. Very complex doing this. You can get an instant quote. It's $2 for 10 boards that big. I'm not a robot. Log in. JLC is the biggest one in China, and they just seem to do. But there are others. I've used PCB Way. They're just as good. It's very competitive. So there's the big, PCB and SMT assembly from $2. That's 5 boards. You could, if you wanted to, and if it's a simple circuit and they've got about 30,000 components listed, you can get them to put it together for you. I've never done it, but probably, well, they wouldn't understand it anyway. So what I'm going to do is order now. It's very simple, isn't it? You do that, click on that, and there's a chat down here, so you get someone, if you spend more than 5 minutes mucking around, add your Gerber file. That's very difficult, so I click on that. I go looking. I think that was in here somewhere. It's gone to the right one because that's the last one I did. Find the zip file. Where is the zip file? Don't you just hate it when you don't? There it is, zip file. So we'll go to that one there. Click on the zip file. I do that. It's now analysing the zip file. It's actually checking that the thing is a good file. It'll spit the dummy if it's not. And you'll see down here, things will change once it's decoded. It's thinking it's a 2-layer at the moment, it's thinking it's about that size. Look, there's my board. It's now picked up its 4-layer, it's picked up its 35 by 72. It's going, do you want to order 5? I go, yes. I'll go down here. It defaults to 1.6, but I make all these 1.2. And a 4-layer printed circuit board that's 1.2, the inner layer is 0.6, and the other 2 are laminated 0.3s. And the reason for that is that the 50 ohm tracks on that are on the top, and they're designed for 0.3 FR4, so just do that. It's the same price. I just want green, but you can have any colour you like, but that adds time on it. 1 ounce copper, gold fingers, no, don't want that. There you go, $7 for 5 printed circuit boards. So it's happy with that. Now, if you want to do a double check, they usually have a Gerber viewer which will do a more detailed look at it. It then does an analysis, checks the drill layers, checks everything else. So if you got your file right, there it is. Analysis report. 4 layers, drill size, minimum drill size is 0.35 mil on that one, 10 mil. That is ready to go. So it's passed the test, hit the button, order it, printed circuit boards, probably 10 days later.
Is that price Aussie dollars?
That's US, so it's 10. Now, I'll just go back and play with the pricing. Very good point. If that was double-sided, it'd be about $2 or $3. That's the cost of them. 4-layer is more involved. I could probably show you some of the earlier. Let's go back. It's up to about 150, then it goes, and we can play around with that just to see the. This is a bit I found fascinating, just the way they do this. Now, for the 4 layers, the 2-layer boards typically just computer analyse, that's it. The 4 layers, they do look at them, they do run it through a checker. When I put my first ones in, it would be like about 3-4 hours processing. But they must keep tabs on what you do and your reliability and everything else. The last ones I put in, they were approved within about 5 minutes. A couple of times, I'd actually made a mistake on the size of vias, so I get a little chat comes back. Thank you, excuse me, but do you need this? And it was actually a track size that was too small, and it came up. So someone actually looks at the more complex ones and just, you know, it goes through like an AI check, but then someone visually looks at 4 layers and 6 layers. It's quite interesting, just watching the. Yeah, dear friend or something. Exactly, yeah. But they're very, customer service. They're in JLC PCB, I think there's over 500 people just doing that side of it. Now, I'll actually put that in my, if I can do it. I probably stuffed it up. That happens regularly. Analysis results. Okay, I'll just go back, put one in again. Order now. You're not meant to go through the Gerber file. I'll just add the Gerber in again. Put that one in. Open. Does its analysis. 4 layers take a bit longer. The 2-layer ones just go like that. Bang. Straight away. Yeah. They make the board. What they do is they start with a 0.6 mil board, image both sides, and then etch that. Then they roll on top and bottom, single-sided 0.3 mil board. Then they drill it. Then they etch top and bottom. I can actually show you. That's probably the best way. Etch top and bottom. And then they do the vias are plated through. There might be a way of actually seeing that.
That certainly makes sense to me.
I'll actually, let's have a look. One of my old orders, order history.
They don't plate through the vias before they get.
They actually do sold it afterwards. So depends on the size of the holes. So let's pick on, that's actually one of those. Let's go back. If I click on that there, production completed, there's the list of what they do. I don't know if you can see it. It basically, they do the inspection, then they do the inner layer, so that's etching the inner layer. Then they laminate top and bottom 0.3mm layers. Then they drill it. Then they do the vias. They do the vias then. They do that. So, and then they image the outer layers and strip it off. Then they plate it. Then they do like an automatic optical inspection. So it just basically looks at the whole thing and checks. And occasionally I'll get extra boards, so they must make more boards than they need and then chuck out the ones that aren't any good. The solder mask then goes on, the silk screen goes on. They then run them through hot air to level the solder. Then they do the last bit is the profiling around the outside, so that's milled. And then they do a final inspection, which is somebody looking at it, and away they go. Now when they do boards, you might only be doing 5 of these or 10 of these. They just lump it in a panel. So if you're doing 1.6mm boards, which is bog standard, green and everything else, they'll do them within about an hour because they're always doing 1.6mm. What surprised me, 1.2mm, which is not a standard size 4-layer, it's usually in about a day and a half before they've loaded a full board. So there's people out there ordering the same boards, the same material. So it just gets chunked on that, and then you can actually watch this online. There's videos showing what the steps are, but you get this little update and you go, oh, okay, on the 16th of August at 13:47, it was laminated. At 6 o'clock on the same day, they drilled it. At 7:30, they did the next step. And sometimes it'll sit for a day, and other times it'll jump. The last order I did, I had 3 different boards, all the same thing. 2 boards got on one thing, and the other one took an extra day. So it must have filled one board up, then they waited for the next one. So it's an amazing system how they do this, but they're doing motherboards, they're doing all sorts of things. So it's, you know, they're going through, you know, like about 10 tonne of printed circuit board a day or something ridiculous like that. So it's just mind-boggling. So that's the easy part. And what I tend to do is then lump together a whole heap of boards, and the shipping charge was $19, merchandise was $35, so there's about 40 boards in there on that order. Now the other thing they do, soldering SMD can be a pain. But professionally, they use something called a stencil. So at the same time, you can order a stencil, and you can make it whatever size. I'll pass this around. And what you do with your design is, there is a layer which is the solder mask layer. So if there's components you don't want to use solder paste, you just turn that off for that particular device. So all that has there is, that's what I've used on that there. So that's
so you just put the solder paste.
You basically squirt it over, get a credit card.
And then squeeze it.
So what I do, I just have this on a board. It's probably not good being that close. So the board just sits on a flat bit of glass or masonite, whatever. I put a bit of tape on that, and this just hinges down and just line the board up. Helps to have a couple of little keepers, so I just use other boards around to do that. So it lays on top of the board, and then you just squirt a bit of solder paste and get a credit card to squeeze it across. And it leaves that thickness, a daub, to do it. So you can pass that around. Yeah. So there's 2 ways of doing SMD. The other one is just bit by bit with gel, flux, things like that. That is so much quicker. The only problem with that is because you're not using glue the whole components in, you can only do one side with it. So what I tend to do is do the more complex side, do that first, and then do the other side, pick and place. You can use it on the top, but it depends how you heat your board up. I just use a flat bit of aluminium on the cooker with a little temperature sensor with my multimeter, get it to about 180, sit it on top, turn it up for about 2 minutes, gets to 200, solder melts, take it off, that's it. You can do double-sided if you use like a rework station, like a heat gun, low flow. And that works, I've done that. It's a little bit more, you've got to be a little bit more careful because it's okay doing small components like that because there's not much heat required, but if you've got a big component, you could end up heating the board up too much. And on these particular boards, because I use vias to couple top and bottom, and on the 4 layers, there's a bit of copper in between. It actually takes a bit of heat to heat them up. And that's great for heat sinks on devices and things because you've got almost, like semi-thick bit of copper there behind it. But it also tends to heat the other side of the board up. But that's, if you're doing it surface mount, you might as well get a stencil. They're $7 each. Away you go, sort of thing. That just makes life a lot easier. And then you just need a big viewing glass to do all the placements and so forth. They're going for time. Yep, pretty good. Okay. That's pretty well it. Now, the program, there are multiple programs around. I use Eagle. Eagle you can get for free, but it only does 2 layers. And that, for most things that people are going to do, that's all you need. So it's you just download it, you can use it, it'll do everything. If you want to do 4 layers and 6 layers, you need to pay money for that. Unless you're doing things like this, you really don't need to. But I found it was the only way to get these things to work properly and take full use of using ground planes on either side of digital circuits to keep the noise out and things like that. Other things I've done, it's been a bit like a needs basis, like the 910H board, which a few people have got already. This one here, Wayne sent me a circuit a French guy came up with. This is a 10 volt or 24 volt power supply for FETs. That's a little bit more leisurely way of just components spread out, but it is actually a low dropout regulator. The whole idea that it has negative volts, has protection if the negative volts disappear. The differential between input and output can go down to about 0.3 of a volt. So for a 10 volt device, you can run that down on a battery to about 10.5 without any trouble, at 5-6 amps. So it was sort of like a universal board. Originally we did it for 24 volts. Well, originally it was for 10, wasn't it? I modified it for 24. Now I've done it for both. But that was a night's work. Drew the circuit out, drew the board up. Nothing particularly critical about it because it's just all DC and things like that. It'll come back eventually. Another board, for one of the SDR projects, I needed an LCD display. So I took about Coles to Newcastle, had 2 goes at this. The reason I needed to design one, there wasn't one that had the right pinouts for those little MCHF SDRs. So bought the LCD display from China for $6 and made the board. Now that board, Wayne mentioned auto routing. This board, all I did was drop all the components and hit the button and let it auto route it. And for digital circuits, which really doesn't matter that much, that's probably the best way to do it. Otherwise you could be dragging all sorts of thin tracks everywhere. And even for analog circuits, it'll do a pretty good job. You do that and then you go and shuffle things around because it doesn't always get it right. But it's certainly a quick way of doing it. Or you can do partial parts of the circuit and do auto routing.
Just a question.
Yeah. It does. You can. The trick with auto routing is not to let it do everything. So, just one more thing I'll show you about the program. That if you've got a favourite circuit that you use all the time, so let's pick. This is probably a good example. Where we go? That one there. Yes. If you've got a favourite circuit you use all the time, you can actually cut and paste like you do, Control-C, Control-V. You can do the same with the board. So you can actually pre-design modules, then put them together, then let it connect together. Like for a circuit, let's say you're using this regularly, it might be a regulator circuit. So all I'm going to do is highlight that and just do this and go Control C and go Control V. There's my circuit again. You can do the same with the board. So the clever way of doing these things is do them in modules and then join them all up together. And in these circuits here, I've got the same regulators and all these and the same phase-lock loop. That's all I've done. Just copy the circuit, junked it across on the new one, and then just fiddle with it to make it work. So that's, and if you're doing digital stuff or analog stuff, you could do that, auto-route it then so it all joins up and away you go. It doesn't always get it right, but it's for digital stuff, it's the only way to go. Otherwise, you're just dragging 16 tracks across and then you find one's not right and all that sort of stuff. So auto-routing, fast PC takes about 30 seconds, a slow PC takes forever, because it will sit there and when you use 4-layer boards, it assumes you're using the inner layers as power planes, so it drops things in there. It's good, but I just, for this stuff, find it's easier just to, because you can see the signal wire. Yes, I must keep that away from that. It doesn't know about RF, it doesn't know about noise and doesn't know about different things like that. So that's probably enough for one session, I suppose. Questions? Here's another one. Here we go. I needed, John VK5KK did a EME controller a few years ago and he ran out of boards for the encoders, so that was another night's work. It's a little PIC processor, nothing fancy, double-sided board. I think I might actually auto-routed that one, just to play with it. So the most expensive part of that was the pro rata percentage of freight.
Freight's a dirty word.
Yeah. And freight at the moment is, unless it's UPS or DHL, it never gets here. That's about how it is. Okay, things to look at. Any questions, whatever? Okay, I'll run through that. So I'll just close it down. What is it telling me? Yes. Okay, I'll just restart it because I had about 3 different versions. When you do Eagle and you open a board, it opens the circuit board and the schematic at the same time. Reason for that is the two are linked. If they get a step, you're in trouble. Because you make a change on one or not on the other. Well, it's mainly the schematic. If something changes, it won't work. So what I'm going to do, I think I've got that circuit up. That's probably the best one. Over on the left-hand side, there is a button called Add Part. Now, it's very hard to see, but there's actually 2 parts to it. It's got a couple of symbols on it sitting there. Next to it is a little drop-down. That drop-down will show you the 10 most common parts you use. So if you're doing normal circuits and things, it'll probably have resistors and capacitors, except because I cheat and just copy things across, it's not there. But it's got PGA 103, mounting hole, FETs, TRA 120 device. That was one I made up. Actually, let's put that in. There we go. There's a 122 gig chip. Just drop that in. So that's, if you hit the big button, that'll bring the whole library up, which is then, now my library is partly default Eagle. If you do a search, you'll find there's some really good third-party Eagle libraries out there. Yep, Adafruit. I've got Adafruit in here. Best thing to do is have a bit of a search and find these things. There's another one called, depending which buyer, whether you go through Element 14 or Mouser or DigiKey or RS, I mentioned all 4, each of them have downloadable parts for the devices or have a tool to create them. But just your normal resistors, you've got resistors born, so that's all your pots, you've got normal resistors, but what I do is I do a wildcard search, so that's just star, whatever star. And if I want to find a 1206 resistor, I'll go star 1206, star, hit OK, and it brings up everything that's in that package side. And probably hard to see, but that's capacitors, that's resistors. Click on that. There's a 1206 resistor. And if you want that, OK, there's a 1206 resistor. We might just have a look at, let's go to Mouser, but you can go anywhere, but let's log in. Let's look at a particular device. Let's pick out something. Steve, what do you reckon? Any 555? You know what that is? Any 555? Do an any 555. This will bring up about 5,000 hits. Only 26, must be obsolete. So let's see. I think the Texas Instrument one looks safe. They've got 43,000 in stock. Let's have a look. And see over here, ECAD model. Click on that. There's your footprint. It's a Julian line, doesn't matter. But that's the symbol for the circuit. So then you just download that. I won't go through that, but there's basically, that ECAD model will have not only Eagle, will have everything. And then you run a little thing called library loader, which I might as well show you what you do. Library loader. And library loader will eventually come up. There it is, library loader, very hard to see, but library loader, once you've downloaded it, it just goes straight to your download folder. But go have a browse, go have a look. Somewhere in here is my download folder, this is there. Here's all the stuff I've downloaded previously. Let's pick that one, do that. Click on that. You've selected Eagle, but you might be running something else. So here's all the other printed circuit board designs, but I just want the Eagle one. Click on Eagle. Open ECAD model. There it is, do that. Go open. Site can't be reached. My phone's gone off, is it? Okay. Why has it done that? Okay, make out it's working and doing something, but what that does then is just automatically download it into the Eagle directory. So that's the way everybody's got it. If you go into, let's share this around, go to DigiKey, let's log out of, get rid of that. So that's how you'll find most of the common parts have that button there. If we go, just get out of that. DigiKey, Element 14 have the same thing. DigiKey Australia, they're not really in Australia. I just like to pretend they are. Log in. Hello David, everybody knows I'm there. Welcome back. Why aren't you spending money with me? So let's go look for NE555 again. You'll find that they'll probably be about 2 cents cheaper. And charge and free freight, $60 over. It's always free freight. Integrated circuits, I've got 35. It's about the same number, I think. I'm sure they must just skim each other's websites and have the same prices. Let's pick on that one. I tend not to use DigiKey so much because their program's a little bit harder to use. ECAD models, Ultra Librarian. So they use another version, but then you just hit on that, takes you to another website, and there's the footprint. You can make up your own footprints if you want to, but go looking. Some of these, if they haven't got it there, you just hit a button and it sends it off and then you get it back. Usually when I've done that, you end up with something totally and utterly ugly like this. That is just, it's just put together very basically, and that's just horrible to use. So you can modify them in Eagle, you can change them, reshaped and everything else, and that's probably why I don't use that website, because it's not as good. Okay, that's probably the long answer, but That's if you can't find it in the library, there are libraries around that you can download a lot of common things, including Mitsubishi FETs and things like that. ERAs, mimics, they're all out there. But if you can't find it, just click on, even if you don't have to buy through them, you just get the part off their website.
Other question is, the one I'm looking at here is a totally different layout on the screen than what you've got.
Yeah.
Just because,
If you've got the, well, there's 3 screens with Eagle. So the control panel looks like that. So you've probably got the, have you got that?
go to the, just file, new, schematic.
Okay, file, new, schematic. Save.
Okay, see all the panels you've got on the right hand side, what are all on the left hand?
You can, I've shifted them across. You can move them. You can move everything around, yeah. Reason I do that, it was stupid having this sitting over here when you're always going to this bar here.
Because I can quite difficult to see those bits.
Yeah. You can drag them around. This panel, this is probably beyond what we need to talk about here, but over here you've got all sorts of, if you've got a very complex board, you can find components, change from that menu. If you want a parts list, that's a blank one, but let's pick a real one. Open recent, let's pick something that's real, that's an old one, won't hurt it. Load the board. You can look at the sheets, look at the inspector, selection. You can then look at junctions, groups, parts, whatever you like, if you want to go looking for certain things. You can create, I don't remember how to do this now. You can do your BOM, your bill of materials from here. Usually just make that up and extract it as a CSV file. But what that'll do is, in Eagle it'll have all the part numbers that were related, like the DigiKey, the mouse part numbers, everything else over in columns. So you can actually create, if you want to, a file you can upload to these websites to automatically order everything. I tend not to do that because half the stuff's in the junk box, but if you're doing this professionally, you can do it that way. So yeah, it's the libraries are updated. You'll always get this bar at the top here, Open Managed Libraries. That's just refreshing all the changes in the library. So it's just updated the library. So that'll have any updates that have happened. So it maintains, you have 2 libraries, you have maintain library and you have your own library, which typically you've made up and it's not linked to anything. But yeah, and that should work, in the free version that should work the same. The premium has a few things turned on. The biggest difference is the support for CAD, so you can actually do a mechanical, if you want to, a housing for 3D printing for the printed circuit board. It comes with Fusion. I've used Fusion, but I've never tried linking the two, except once when I made those plastic things there. Okay, that was probably the long-winded answer for that question too. Any other questions?
So that I just think back a long time to when none of that was going. When I went to uni, they started teaching people about what was the basis of transistors.
Yes. It's the one thing that's made this, probably brought electronics back, is the maker side of it. And looking at, most printed circuit boards are made by, if you take the commercial stuff out, which is motherboards and things for everybody, most of it's pretty well at that level. There's so many projects. Using Arduino, there's a template you can get that just drops the Arduino and then you can just put whatever you like on top of it, sort of thing. But yeah, it's probably one thing that saved the enthusiast electronic thing is this maker thing. And it's just a bit of fun. When I was working in Melbourne, pre-COVID, I would quite often do this stuff over there because I had nothing else there. So a lot of the boards sort of happened then. I don't do that much now. But it was something you could do on a plane. And it's actually, especially 4-layer boards, it's a very good brain exercise because you really have to think what you're doing. And yeah, you sort of tend not to do it in one session. Probably some of the boards, now I've got these templates, you could probably do them in 2 nights. But I think the original ones took about a month. And that was mostly learning the shortcuts and different things like that. Yeah, having designed boards before, we had a bit of an idea how to do it, but it's just totally different to what it used to be, especially when it was the old tape method. Okay, so it's gone from there, 1990, to this stuff. Righto, that could be it.
Fairly informative. You've seen the process from Dalo pen, which probably cost you about $7, to now buying 10 boards for $7 with silk screen and wires and
Yeah.
much neater. Thank you.